Everybody is ready? Let's go. So, perfect. Thank you for being here. I'm Jonathan Lasalle in French. And here is Benoit VIAUD. With our presentation, we will show you ways to manage large EMF models in a RCP application. So first, some background. Treacherous is an application dedicated to the design of complex system simulations. Which complex system we can talk about last Airbus aircraft, such as A380, A350, but the software can address all contexts such as avionic, automobile, rail, and so on. So our application has some needs, some technologic needs, functional requirements. First, we need to have some box and rows diagrams. For those representations, we need just some, I don't know, hundreds box that represents components, the aircraft components, engine, so on. We have also some Excel-like tables. For them, it's not the same. We have around millions parameters. It represents, for example, the signals that are sent from one component to another. We also need some data validation. We use OCL, so the user can write its own OCL rules and validate the data using them. We have also query and export process to generate simulation files, for example, to communicate with simulation platform. And we want to support the metamodel evolution. So, for example, we can use edapt to manage it. So, with a touch of EMF, just a little bit. So next, if you want to develop such kind of applications, the first solution is to have to use a basic RCP application with a basic EMF resource management. You will use XMI files and you will try maybe to implement some lazy loading mechanism to not load everything in the memory at the beginning. When you have several millions of parameters, yeah, I think you will need them. The unloading is not the simple mechanism you can implement in EMF. You can try, but yeah, not very easy. But at the end, for some treatment, for some features, you will need to have quite all the model in memory. And so when you have several millions of data, you will increase your memory and more and more and more, and your computer will say, stop, I can't more. I swap a lot in my old disk, and the performance sink directly, and you have failed. So one alternative, the first one, a lot of people knows it, it's CDO. For those who don't know, it's quite simple. On this slide, it's quite simple. You have a database. In our case, we use H2. You have a layer which is called the CDO server, which will communicate with the database and will communicate with the application, transform the entries of the database into objects in your application. And one good feature in CDO is that you can communicate with several applications, and so have a lot of nice features, which are, for example, the branching, auditing, conflict mode, and so on. Yeah, and you have those mechanisms, lazy loading and unloadings, which are quite nice. So why not? Good solution. So we used it. And we had some problems. First, concerning the insertion and the deletion costs, it's not so good. It's linear, but it's not so light. And for RAM consumption, yeah, you don't need as much memory than the basic solution, but it needs a lot of RAM, and we don't really need when it releases the objects, and it's quite opaque. Why? But just because there is a full client server manager with several layers with the constraint on database. So yeah, it explains the cost, and yeah. So which other solutions we have? So first one, we can take the basic solution and trying to make it lighter just by implementing lazy loading, by using lighter e-objects. Why not? It's quite easy to implement and quite no impact on the application concerning development. But the problem is that for transversal model queries, such as exports, or you will have the RAM blast, you will have the same problems with all objects in memory, and so millions of objects in memory, it's not possible. So this one, it's good, but yeah, third place. Another solution can be to improve CDO, to try to change the mechanism to make it lighter. So for example, you can merge the management layers, merge the server and the client, because in our case, we don't need any client-server mechanism. We are on a basic use. If you have a CDO application, it's free, no problem. You just have to patch CDO. The problem is that it's quite hard to patch CDO. It's doable, but yeah, not so easy. So we can put it on the second place. Another solution is to go before CDO. Before CDO, there was Teneo, which was quite the first solution on an RCP application using a database. So in this case, it's an out-of-the-box solution. Like CDO, you just have to put it to replace your persistency layer, and it works. The problem is that it's quite opaque, it's not maintained, and yeah, and there is no unloading process. So same problem. For this one, yeah, we choose to let it aside. Another solution can be to use proven solutions that in Java mode, in Java context, are really old and maintained, and yeah, it's to use Hibernate Java Persistence API, JPA. So Hibernate, just manager for those who don't know, it's quite a layer that helps the communications with the database, which allows the persistence of in a database. The JPA is dedicated to the building of Java objects from the database entry. And so we are in a RCP application, so we need a conversion from POJOs to e-objects. The pro is that an handmade solution, so perfect, we can do what we want. The problem is that we have to do everything because it's an handmade solution. So first is one, maybe it's a good solution, so we'll put it on the first place. And the last solution, there is other solutions, but another one can be Neo EMF. It's quite well built. It's quite maybe a good solution. It's based on a graph-based database. The problem is that we considered it at not mature enough. And so the podium is full, so sorry for it. But the last time maybe. So now, what do you want? You want numbers, because you like numbers. So a lot of numbers, well, not so much. So we compared the two first place of the podium. And for example, so we improved CDO. We tried to merge the client and the server layer, made some improvement. And for example, just for insert around 1 million objects, but not simple objects owned on one list. No, it's objects with some dependencies, with some references. It's a complex metamodel. It took 1 minute for CDO and only 30 seconds for Hibernate GPA. So quite good improvement. For update process, it's not so bad, from 10 minutes to 30 seconds. But for the data export, using query, it's quite the same because we go directly in the database, so no problem. It's quite the same time. But for the delete, there is a huge difference. So with quite near 100% less. It's quite good, I think, maybe. So why we have this difference between CDO and this Hibernate GPA solution? Here is the structure of our solution. We have a database, okay, we used H2 in our case. We have a GPA layer, which will manage the objects, the insertions in the database. A converter, which will be able to convert POJOs to e-objects. In the application, you will have to put your process in one layer or another to have the best results. For example, for insertion, for data import, you will insert a lot of data in your database. You will communicate directly with the GPA layer without having the objects you don't need, because you are just putting items in the database. For the data addition, the same thing. We will directly communicate with the GPA layer. Don't need of e-objects. You can directly call the GPA layer. For the same thing, it's the same thing for data export or for complex algorithm. If you want to get all data, create connections, if the name is the same or so on, you don't need to have the objects. That's true, okay. Excuse me, I'm a little bit lost. Okay, and then when you have such kind of algorithm, you can try to directly access to the database without using, or just a little bit, without using the GPA layer. You will directly launch a query which can return directly the value you want to write in your file, so you don't have to build any POJOs, you just have to get the values. And on the other side, you can have EMF process for Sirius editors, for Nebula editors. And so for those steps, you will connect, for the OCL validation too, sorry. You will connect to the EMF layer, which will communicate with the database using the converter. Okay, no problem, it's like basic mechanism. No problem with that. Just you have to think about something that if you have e-objects displayed in the editor, and if you launch at the same time a complex algorithm which modifies the data, you have to synchronize your POJOs or your database items with your e-objects. So you will have to synchronize each time you do something in the GPA layer. You have to synchronize data with the EMF versions. So now, how to explain really the delta between the CDO result and the Hibernate GPA result. So, for example, we have, for metamodel, one bus can contain some signals, some million of signals. In CDO, we'll have this structure concerning the database. And so if you insert a bus, it will insert an entry in the bus table, and one entry in a CDO objects table, which lists all objects you have in your model associated to its type. Sorry. If you insert a signal, the same thing. You will insert it in the CDO objects table and in the mapping table, which links the bus and the signal. No problem. The problem is that when you want to delete it, it's the same cycle, but you have to work on e-objects. So you have to load, if I want to delete the bus, I have to load the bus, to load all the signals. I don't do it manually, but the system load the objects, and it will delete the bus, and so on, in each table, the associated data. So it's quite a lot of steps just for deleting one bus, and some objects and those, but you have to load a lot of data. If you have 1 million of signals, it's a lot of data, yeah. So the database mechanism is quite heavy. And another thing, if I restore my data, oh, magic. If I add a new part in the meta model, just some simulation parameters that can simulate the given signal. I will have a new table just with 1 new entry, for example. And so if I reapply my delete, if I call the delete on the bus, I will have a magnific error because this value is transient. Okay? Because CDO by default doesn't clean the reference except if you use the core-util.delete, but you need to have your objects in memory and so on. So you are not sure that all references are cleaned. So you have to do it manually, or you can develop a mechanism dedicated to this problem. It's what we did it. We developed deletion dedicated to CDO, where we use the CDO cross-referencer to obtain the list of objects that are impacted. So imagine if I delete a bus that delete 1 million signals, I have to find manually 1 million of simulation parameters which reference the signals. And after I have to clean them or to delete them. It depends. So what about the Hibernate GPS deletion? In this case, we will not have the CDO objects tables, and we will not have the bus signal table. So less table, less entries, less time. And then we will have real foreign key. What is a foreign key? In database, it's a real link between entries. If you have no foreign key, it's just a value, and you have to check the fact that the value is okay. In this case, if you have a foreign key, you will have a direct link. So, and we have another foreign key in this case, okay? And so when I will delete the bus, automatically the database is able to clean the value. And it's the database. It's not our process, it's Hibernate and the database. So it will automatically destroy the signal. So first one, the mechanism is quite better. And if we want, it will also clean, the database will clean the reference. Clean or delete, it depends, I can configure it just by saying, please delete it, please clean it. In the meta model, in the definition of the application, and not in the code. So it's quite a good improvement. And yeah, the last point is just that you have to synchronize your database with the loaded objects, the objects you have in memory, because yeah, you have maybe deleted them and they were maybe displayed in editors, so you have to inform the editor that the object is no longer available. So next, how to build it, because it was done, all those steps were done in a benchmark, in a sandbox, just to try. But after we had to generate them, to make it generic. For the first steps, it's easy. Just to take a GPA definition, inject some Texo which can help you to define a GPA layer. Add a database, an Hibernate database. Okay. For this part, everything is perfect until the trouble begins, and so you will have to delete to implement the fact that you must have foreign keys by modifying maybe the meta model, by applying some rules. You will also have to implement a lazy loading mechanism. And the best is to being able to unload e-objects to not have the same problem with growing up memory and having the same problem. And just the last step is to refactor some algorithm to be able to have the best performance and to not load 1 million parameters to open an editor, for example. So what is the result of this work? We obtained a technical framework which is quite packaged. We can use it like CDO, for example. So which contains the definition of a database, the definition of a GPA layer, which deletions helper, API for query, and we have the EMF layer, so which contains the converter. And for the converter, you will have several views. The first one is the converter with a lazy mode, which will convert the POJOs to EMF only when you need them. You will navigate through the model step by step. And you will store already converted e-objects in order to not convert them several times in the same process, for example. And you have also a sharing mode that allows you to convert all your part of a model without lazy mode. If you want, for example, export your data to a basic XML resource, because you want maybe share your data. So you will be limited by your RAM, your memory size, because you will have to load a lot of data in your memory, but why not? And another point, there is some connectors, for example, for Sirius, because the structure is not quite the same than a basic EMF application. So you will have maybe to configure your application to have what Sirius needs. And after, you have communication between them. And with that, you have just to deploy it on your application and to apply a lot of good practices, just to be sure to do the right things, to have a lot of foreign keys and so on. So, I will let Benoit speak. Yeah, that's it.
And
I lose the floor.
so, if you are in the same situation than we were something like 6 months ago, meaning that you have developed a nice RCP application, and actually so nice that users are putting more and more data into it, and that they start to experience performances issues, or at least that you fear that they might at some point. Then our solution is a path to help you in this situation. So here is a little roadmap that may help you to make the good decision. So the first thing is to be sure about your requirement for performances, and meaning that my application should cope with huge amount of data is maybe not a good requirement. So you have to think a little more about, do you need to have a large import of data? Do you need to have fast deletion? Do you need algorithms that deal with all the data in memory or just little parts? And if you don't, and if you also need advanced feature like the one that John mentioned about CDO, branching, auditing, concurrent access, and so on. And so surely if you need this, then you are willing to sacrifice a little bit the performances for this kind of feature, and definitely consider using CDO if you want all this. But if you are in the same case as we were, that you don't need that kind of feature, and that for you performances are never good enough, Then you could try this kind of solution that we have set up. So the first step, it could be done in several steps. So that's the before using our solution, you should consider this. And then the first thing is to introduce the framework. Exactly the same that you will do with CDO. So you have your basic EMF application. You want to go with CDO, so you have to change a little thing. It's not that costly. And especially if you already identify and have all the resource management in a single place, it could be done in a few days. And with this, you already have the daily loading mechanism and a faster deletion, as John mentioned. So that's the first step, but you don't have all the benefits. Second step is to refactor the meta model. One main guideline would be to change the contains relationship and to use opposite references, meaning that the parent doesn't know children, but the children knows its parent. And you should do that for a very large amount of data. And the change of the meta model could be very straightforward and is not costly, but you have to adapt the code to this kind of change. And once you have this, you could take direct benefit from the unloading mechanism, and so you have less objects in memory, and so you, when you delete something, you don't have to synchronize all the objects already loaded, so it's direct deletion in the database, and it's extra fast. And final step, and you could do all this at your own pace and having what you want first. The last step would be to change your algorithm. And typically some algorithms are really fast when being closer to the database, when you need to optimize queries. Things like, I want to give me all the signals that have the same letter than the output signal in other interface. That kind of algorithm are very fast using SQL. So this could be easy to medium or high complexity, depending on your expertise with these technologies. So that's what we've done. The framework itself is not quite big. Actually, it's something between 10,000 and 20,000 lines of code. It's just an integration of proven technology like Hibernate and conversion and so on. So, but small in this case is maybe beautiful. And we are at the beginning of this thing. We have done it for us. So we are still wondering if this could interest other people. So one thing could be to publish our benchmark with CDO. We have just presented CDO, but we also have pure SQL benchmark. We have different technologies. So we have a neutral benchmark to evaluate this, and the figures that John gave you was from this benchmark. So if in the among you there are techno providers for this kind of technology, we could exchange on this, or maybe you are an application like I've mentioned, and maybe you are interested in such solution, and then we could try to publish the solution we have developed. So we have not our mind clear on that. It would depend of the feedback from you people. And so we have a booth if you want to come by, and we could decide if you are interested or not in this kind of solution. And maybe in the next months you will see something popping up in GitHub with these technologies. Yes, I guess you have seen the. So, any question?
Really useful, maybe for my public intention. In our case, it's like you see on the framework, there is a converter dedicated to the sharing. So in our case, if we want to support the edapt, we will share all the model using basic XML files, and so we import them with the new version of the tool, and so we'll be able to use edapt on it because it's basic EMF resource with basic e-objects inside it, so we can load them, migrate them, and insert them inside the database. So it can be a little bit heavy, but we are able to export the model by part, just some small part each time. So we have maybe 100 files, 100 XML files, why not? And so you can re-import them and migrate them as you need and migrate them. Yeah. For me it's quite good. We used it previously on the CDO application, and for me it worked well. So yeah, we used it. I'm not sure to understand. Does it need more features or? In our case, yes, it's fully automatic. The application needs just to have the eCore model with the history file. So in our case, we have everything in our application. So the user don't see it. It just sees that he must export the models before using the new version of the tool. That's the only constraint. He cannot open the old workspace with the new application. It has to export it and to import it. So it's not fully automatic, but the user accepts to have to export all its workspace and to import it with the new version of the tool. That's all. Thank you. Right.
I understood correctly, you have both an EMF model and an enlarge tool. So if you need to modify the model, you need to modify it twice.
We have only one metamodel. One for EMF, which is the same for GPA. So when we modify one, we just have to generate twice the classes. We have to generate the e-object classes and the GPA classes. But it's one generation, one automatic generation, just one click, 2 clicks, one for the gen model and one for the GPA generation using Texo tool. But only one metamodel, it's the same. That's why we are able to synchronize POJOs to EMF and so on, and the other way. Okay.
Did you consider in your benchmark to update the gen model file in order to reduce the memory footprint of generated code?
Did we do that? That's a good question.
At least we have the idea of having very small footprint objects, but in the end we have so many objects that we could gain something like 20%. That would be the best case, but still that would be the very small memory. So that's a good step maybe, but it's not enough. So that was not a long-term solution.
You're right. Thank you. Okay, no more question? So if you need, and we are just...
Yeah, and if you don't believe in the performances ratio, we have two versions of the application. So you could compare.
Yeah.
See that it's really working.
Yeah. Thank you very much.